All right. This last section involves examining the roots of the equation formed in the process of solving two curves simultaneously. So we've got two polynomials. We're looking for point of intersection, and key focus is going to be on the x value of the point of intersection. So imagine I've got two curves. I want to work out their point of intersection. I solve simultaneously, and I can bring this q of x over the other side. So finding the x value of the point of intersection is equivalent to finding the roots of this polynomial equation. Okay, I'm going to skip this little bit of theory. We'll get to it when we have to do a question. This one here. The line y equal 2x meets the parabola, that parabola there at the points A and B. And they've called A alpha comma 2 alpha, and maybe you can see why it's 2 alpha, because if x is alpha, the y value will have to be 2 alpha, because it has to lie on the line y equal 2x. Okay, and the point B, we're going to call it beta, comma, if x is beta, then the y has to be 2 beta, okay? So let's sketch the situation, okay? So I need to sketch these two functions. Y equal 2x is very easy. The parabola, though, let's do a bit of work with that to sketch it. It's nice that we can factorize this parabola. Okay, so times to give -8, add to give -2, so -4 and 2. So that means that we've got x-intercepts. If you set y equal to 0, you've got x-intercept of 4 and an x-intercept of -2. Y-intercept, set x to be 0. I think it's easiest just to look at the original. If you set x to be 0, you get y equal -8. Vertex, the x value of the vertex is minus b over 2a. I'll look at the original again. Negative of -2 on 2 times 1, which convince yourself the x value of the vertex is going to be 1. And if you sub 1 into this equation, you can quickly see that y is going to be 1 minus 2 minus 8, which is -9. So the vertex is 1 comma -9. Alright, I think I have enough information to sketch. Should probably draw a bigger sketch than this. Okay. One, two, three, four. Okay, -1, -2. Okay, 1, 2, 3. Let's go up by 4s here. 4, 8, 12. Down by 4. -8. -12. Okay, so x-intercepts of -4, sorry, -2 and 4, y-intercept of -8, vertex at 1, -9. Okay, that should be enough to draw my parabola. Oh, there it is. Oop. Okay, so that's my parabola drawn. I'll label it y equals x squared minus 2x minus 8. The other line is y equal to 2x. Okay, so when x is 2, y is 4. When x is 4, y is 8. -2, it'll be -4. Okay, got enough points there. Draw a line through. Okay, so we can see that the line meets the parabola at 2 particular points. One is going to be point A and one's going to be point B. For no general reason, I'm going to let this one be A and this one be B. Okay, and the x value there will be, beta, and then the x value here will represent alpha. Okay, I could have switched A and B, but for this question I'm doing it this way. It gave me no information. Maybe the question should have said something like alpha greater than beta, and then you could know how to plot it. Okay, A's done. B, show that alpha and beta are roots of this equation. Hence, find the coordinates of the midpoint M of AB. Okay, so first thing, I'm after the points of intersection. So I'm going to set these two equations equal to each other, the right-hand side. So I'm looking for points of intersection. So I'm going to set x squared minus 2x minus 8 equal to 2x. And then I'm going to minus 2x from both sides. Okay, so that there is what we're required to show for the initial bit of the question. So that's that bit done. Okay, so the solutions to this equation will be alpha and beta. Hence, find the coordinates of the midpoint. Okay, so the midpoint of AB. Now, there are two ways of working out the midpoint of AB from here. Okay, method one. Actually, we'll scroll up, I'll show you. So method one would be to actually solve this quadratic, work out what is alpha, what is beta, like we can work them out, and then the midpoint will obviously be alpha plus beta on 2. Okay, so solve the quadratic equation. For one of the answers is alpha, one of the answers is beta, add them, divide by 2. That's method one. Method two, which is quicker, is just use sum of roots formula on this guy to work out what alpha plus beta is. And then what I'm after is alpha plus beta on 2. So I'm just going to take that and divide by 2. So I actually don't need to find out the exact value of what is alpha, what is beta. All I need to do is just think cleverly. And that's the key message of these last two examples of the booklet. Sometimes you don't need to find the root. Okay, sometimes you can use sum and product of roots to get useful places without actually finding the roots. That's the key message. Okay, so let's do sum of roots. It's minus b over a. So the roots of this guy are alpha and beta, so that means that alpha plus beta equals to minus negative 4 on 1. So alpha plus beta is 4, which we're after alpha plus beta on 2. That'll be 4 on 2 or 2. So that means that the x-coordinate of the midpoint, because remember alpha and beta are the x-coordinates. So therefore, x-coordinate of M is 2. If I want to work out the y-coordinate, convince yourself that the midpoint has to lie on y equal to 2x. Okay? The line connecting A and B is y equal to 2x. So therefore, the midpoint has to lie on y equal to 2x. So therefore, the y coordinate would just be 2 times 2, okay, which is 4. So therefore, the midpoint is 2, 4. Okay, and if you look, kind of looks reasonable that this equals to this. There's your midpoint. Okay, so that's part B done. C. Use the distance formula to show the distance from A to B is given by that formula. Okay, so A is alpha, 2 alpha, B is beta, 2 beta. The distance formula, square root x2 minus x1 all square plus y2 minus y1 all square, sub in. Okay, let me just check if it's alpha minus beta. Yeah, alpha minus beta. So I might call this guy the alpha x2 y2 and this guy x1 y1. So let's go. So that'll be x2 minus x1, so alpha minus beta all squared, plus, and then this guy minus this guy, so 2 alpha minus 2 beta all squared. Okay. And then what I'm going to do, I'm close, I need a 5 there, so 2 squared is 4, right? So I'm just going to go, what if I factored out a 2 here, 2, and then there's a squared. So I factored out the 2, but then I've also got to remember that if I do that, I've still got a square. So we get that d is equal to square root 5 alpha minus beta all squared. So that's the distance between A and B. Alright, that's that one done. D, use this identity to find the distance AB. Okay, so I'm going to do D up the top of the page here. So obviously we're going to start from the distance AB is equal to square root 5 alpha minus beta all squared. I'm going to use this identity here. Now this identity we used a lot when we're doing sums and products of roots, so it gives me an idea that I'm probably going to need to use sums and products of roots. Actually, I'm going to split this. I'm going to bring the root 5 out the front. Just going to leave that root 5 there. Okay, this guy here, I'm going to apply this formula here. Okay, so that's the distance of AB. Now, this is just the sum of roots. This is just the product of roots. So the sum of the roots was 4. If you do the product of roots, C on A should be -8. So alpha beta should equal to -8. Okay, so sub in. So 4 squared minus 4 times -8. Alright, let's keep simplifying. So it's 16 plus 32, which is 48. Take out the square factor of 16. That's going to be 4, and then root 5, that's going to be root 15 units. So that's the distance between A and B. Okay, see you in the next video.